So we're going to start to or continue to work with the quadratic formula, and we're going to be working with quadratics that could have complex solutions. So it says solve each of the following quadratic equations using an appropriate method. Express your answers in simplest a plus bi form. So if you're solving a quadratic, it can be super confusing that they're talking about these complex numbers, but that's just a hint that you're not going to be able to factor. So I'm actually going to go out of order because I have a certain levels of difficulty and I probably should have organized these differently, but I'm actually going to start out with letter E. So first off, I could look at it, I could see if it factors. I don't know any factors of 25 that add up to -8. Plus I have that hint about the a plus bi form, so I'm going to skip right to the quadratic formula. So my a value is 1, my b value is -8, and my c value is 25. So we have x equals -8 plus or minus the square root of -8 in parentheses squared minus 4 times 1 times 25 all over 2 times 1. From here, I have 8. I'm going to type in that discriminant, the number under the radical, and I get a -36 there. And then this is all over 2. So I notice 36 is a perfect square. I have a negative number, so I'm going to have an I there. So I end up with 8 plus or minus 6i over 2. So looking at those 3 terms, my common factor is 2, so I can divide each of them by 2. And my final answer is 4 plus or minus 3i, and on delta math, you would enter that as 4 minus 3i and 4 plus 3i in either order. So the next one I want to look at is back up the page, letter B. So we have 16x squared plus 25 equals 0. Now, I noticed on this one that I could use the quadratic formula because I always can, but incomplete quadratics are going to be easier. And I actually think your teacher, whether it's me or Miss Morrow, is going to go over both methods in class and how that could work because it's going to be a little cumbersome on the video. So since it's incomplete, I'm going to move over the 25 and divide by 16. Okay, because we don't have an x term, so we can isolate the x squared. So from here, we're going to take that square root on both sides. We need to remember our plus or minus. The square root of 25 is 5. The square root of 16 is 4. And because we have a negative radical, my answer is going to have an I. So I can split that up into my 2 answers. So the third one we're going to go over, and these, it's really pretty basic. The rest of them are all going to use quadratic formula because we do have a bx term, but there's different types of simplifying at the end. So I actually want you to do D and then C. We're actually going to skip A, and then F. So I actually think if you pause the video and try them all and then just kind of come back and check with the video, you can even check the answer and then go back and watch that beginning of the video or the explanation if you need to. That would be the best for you. So I'm going to go through now. Hopefully you've done them yourselves and do the problems. So first off, we get it in that standard form, and now we're going to start to plug the numbers into the quadratic formula. And if at any point you feel like I'm not explaining enough on this quadratic formula, I'm kind of assuming that you got it the first couple times through. I would just go back to that quadratic formula video about how to plug the numbers in from a couple lessons back. But for now, we're just going to go kind of fast so that you can check the questions quickly. So this ends up simplifying to a -8 if I type it in. So here, that's not a perfect square. I see I have an I in there. So I am going to simplify the radical. This is -4 times 2 is how I would break up the square root of -8. So that's going to give me 2i radical 2 over 2. So from here, we're going to see what can we cancel from each of those terms. And sometimes it's nothing. It could stay like that. So I get negative 3 plus or minus 1i radical 2 over 1. Now to simplify that, I don't need this divided by 1 or the 1i. So in order to have this in a plus bi form, we want negative 3 plus or minus radical 2i. And I think I checked on this part. The delta math does want you to have that I last. So just be careful that you're doing that. If it doesn't work, try it the other way because you have those two opportunities to get the question correct. So our next one is C. So this is x equals negative 7 plus or minus the square root of negative 7 squared minus 4 times 1 times 20 all over 2 times 1. As I said, hopefully you've done these yourselves because I'm just, I'm not really giving you time to type stuff in the calculator now. So if you need to pause the video, you didn't, you can. So I have 7 plus or minus the square root of negative 31 over 2. So this one we see is not going to simplify a whole lot. I can't leave the negative in the radical, so I am going to have I radical 31 here over 2. So that is the correct answer. Now we just have to get it into a plus bi form. So the way we do that is we're going to distribute the 2 and write it in both fractions. So that gives me 7 halves plus or minus. Now this fraction, just this one time, I'm going to write it like this, okay? But to get it to a plus bi form, the 7 halves, and if I could reduce 7 halves, I would, but I can't. So I'm going to write this number first, radical 31 over 2, and then I'm going to put the I next to it. And that's a property with fractions. You can take out pieces of the numerator and multiply by that. This is still equivalent, but that is in a plus bi form. So our last one we're going to go over is letter F. And in terms of the type of simplifying, question or letter A is very similar to this one, so I'm just trying to keep the video a little shorter. So I'm going to subtract my 12x and subtract my 5. And I get 8x squared. Let's erase some of this to get out of the way. So 8x squared plus 24x plus 19 equals 0. So even though I know this isn't really a factoring section, that might not even be something I want to factor. So remember, quadratic formula is also great when it looks like it might take a really long time to factor to get your solutions. So I have negative 24 plus or minus the square root of 24 squared minus 4 times 8 times 19 all over 2 times 8. So we have, some bigger numbers on this one. Let me just move the page down a little bit so we have room. So looking at this, that's going to give me negative 24 plus or minus. Now this section here, okay, is going to simplify to, it looks like it's going to be ugly, but it is actually a negative 32 over 16. So I have negative 24 plus or minus. When I break up that square root, that's negative 16 times 2 over 16. In my screencasting software, I'm not really able to move the screen down because my smartboard is not super centered. So I'm going to bring this problem over here to continue simplifying and give myself some space versus messing up on the video and having to start a new one. So I have negative 24 plus or minus 4i from the square root of negative 16, radical 2, all over 16. So because I'm going to a plus bi form, we're going to see actually that you might end up with different denominators on the two fractions. So I'm actually going to split it up from this spot this time. So I have negative 24 over 16 plus or minus 4 radical 2 over 16i. So I did a couple steps together. I took this fraction here, okay, and I kind of set it up with the I after. So now I'm gonna reduce each of those fractions, and since we're in A plus BI form, we could reduce differently for each fraction. So this one has a GCF of 8, so I'm gonna have -3/2. And this one has a GCF of just 4, so I'm gonna have 1/4. So looking at this as a final answer, this is gonna give me -3/2 plus or minus radical 2/4I, because I just had a 1 up here. Okay, so that's your final answer on that one. And if you were typing it on Delta Math in A plus BI form, this is like the problem with a bunch of arrows all over the page, sorry about that. This is -3/2 minus radical 2/4I would be your one answer, comma, -3/2 plus radical 2/4I. And it does not go further than this. This is the most complex things are gonna get. We are actually gonna leave the problem on the next page for class time. I will make a video for the people that are remote, but it doesn't really go along with the questions, and it's more of a thinking thing